A semicircle is inscribed in an isosceles triangle with base 16 and height 15, so that the diameter of the semicircle is contained in the base of the triangle as shown. What is the radius of the semicircle? So I will start with naming the triangle. I have A, B, C, and they are saying that BC, which is the base of the isosceles triangle, also has the diameter of the semicircle. So that means that if I were to drop a perpendicular from A onto BC, it would be the perpendicular bisector. So AE is a perpendicular, not AE, let me name it as AO, because the perpendicular bisector of BC is where is the same line that's going to pass through the center of the circle. So AO being the perpendicular bisector, O is the center of the circle. So O is the center of the circle. So BO equals OC anyway, because AO is a perpendicular bisector. And BC we are given is 16. So BO equals OC equals 8. And AO we are given is 15. So we can find out what AB is, because triangle ABC is right angled. So we can say that in triangle AOB, AB square equals AO square plus OB square. So AB square would equal AO is 15 square plus OB is 8, or BO is 8, so 8 square. So AB would be the square root of 225 plus 64, that equals 982, and that equals 17. So I get AB equals 17. So once I have that, I am going to try and work out the radius. So to do that, I am going to draw a line, which is a radius, from the center to the tangent. Now AC and AB are tangents. So AC and AB are tangents. And we know the radius is perpendicular to the tangent. So we have this as perpendicular. So if I name it P, so I can say OP is perpendicular to AB. So, and if I name the radius, if I just call the radius as R, because I don't know what R is, that's what I have to find out. So this is R. So OP equals R. OP equals R. And then what we do is we can so we can find out what PB is in terms of R. So I can say that in that way, in triangle POB, OP square plus PB square, OP square plus PB square equals OB square. So PB square can be written as OB square minus OP square, and that equals OB square is 8 square minus R square. So PB equals square root of 64 minus R square. So once we know PB, then we can try and work out what AP is. Now AP is AB minus, now So let's do this. So we can box it. I don't want to use the next slide. So I can say that AB minus PB equals AP. So AB is, I know, 17 minus square root of 64 minus r square equals AP. Now this is not a very good looking number, but we will work with it, and in the end it should work out okay. So AP we have found out. So 17 minus root 64 minus r square. We have to find out r square. So let us consider triangle AOP now. So let us consider triangle AOP. So in triangle AOP, you see we can write that, we can work out the Pythagoras theorem, like, so we know the hypotenuse is AO. So AP square plus OP square is AO square. So we can say AP, that is AP square, so 17 minus root 64 minus r square, and the square of this, and plus r square should give me AO square, which is 17, which no, AO is 15, should give me 15 square. So I have to solve what r is from here. Looks a bit difficult, but let's get on with it. So if we do the square of this, so 17 square, so we get 17 times 17 is 289, and minus 2 times 17 is 34, and then root of 64 minus r square, and then it is plus 64 minus r square. That's the square of 64 minus r square. These are the roots, so this becomes this, and then plus r square, and that is 225. So now what we get is, if I do, you see this r square and this r square cancel out. So I'm left with, if I take this entire thing on the right hand side, this thing, then might look a bit neat. So I would get 289 minus 225 plus 64 equals 34, and square root of 64 minus r square. So I should get from here 464 and 64, right, plus 64, and that is 128. So I get 128 divided by 34 equals square root of 64 minus r square. So I can do, now if I do squaring both sides, then I should be able to make some progress. So I should have to write 128 times 128 divided by 34 times 34 equals 64 minus r square. Or I get r square, I would get from here, that implies r square equals 64 minus 128 times 128 divided by 34 times 34. Now we have to work this out. So what would happen is, we get 128 times 128 equals 16,384. So that is 64 minus 16,384 divided by 34 times 34 is 1156, and that equals 64 multiplied by 1156, and that is this, minus 16,384, and that gives me 57,600 divided by 1156. So 57,600, that is r square. So I can write, so you see, if I do the square root, see this now, this thing, so r would be, if I can bring this down here, this black pen. So from here we get r would be the square root of 57600 divided by 1156. So 57600, the square root of that is 240, and r equals, and the square root of 1156 I think is 34 square root, and I get 34. So r is this. Now if I simplify it, I should get 2 times 12, 120, and 2 times 17. So I get r is 120 out of 17, and that's the answer. So I would get, what is the radius of the semicircle? So the radius equals 120 out of 17, and that is the answer.